In this section, we teach you how to work with positional parameters. Now, when a script is run, it can accept parameters or arguments on the command line and use those arguments for further processing somewhere within the script. The number of arguments that you can pass in is virtually undefinable or virtually infinite. Nonetheless, you typically will pass into any useful script maybe one or two parameters, one or two arguments. We're going to show you how to use positional parameters, how to echo the number of positional parameters that Bash has recognized as being passed into the script. We'll also show you how to set up a condition for cases where scripts that actually require X number of positional parameters can at least alert the user and not run the rest of the code base until the user completes the proper usage. You'll find this sort of syntax, this sort of control in even some of the scripts that ship with your Linux distribution. Let's open a shell. And as usual, we'll navigate over into temp2. That's where we have our list of scripts. Now, any of the scripts here can echo for us the number of positional parameters that have been passed to it because it's something that Bash keeps track of. Bash keeps track of, for example, the command that we run and anything thereafter. So, for example, when we source for loop 1.shell and then any values after, separated by spaces. Now, positional parameters are separated by spaces. So, for example, if we pass a value of 1, this is the first positional parameter. A next value of, let's say, 2 is the second positional parameter. Now, there's no correlation between the numbers here, 1 and 2, and the actual positions. For example, position 1 could contain a value of 3, and position 2 could contain a value of 9. Nonetheless, they're occupying positions 1 and 2, which is why they're called positional parameters. Let's create a new script. We'll touch pos param for positional parameter 1.shell, and we'll work on it. Show you how this works. As usual, the header goes in. And the author, date, and it's good to also put purpose, etc. And we end. Excellent. The first thing we want to do is echo the number of positional parameters that this script sees. Now, the script does nothing. However, we can echo the number of positional parameters. That is stored in a variable called $. So we execute or we echo the variables by specifying $, and the name of the variable is actually $. Now let's exit. We'll show you. We'll source pos param 1.shell, and as you can see, the value returned is 0. Now let's pass in a parameter as we were doing before. Let's pass in a parameter in the first slot. We'll call it 1. And as you can see, the value is 1. In other words, it recognizes, Bash recognizes that we've actually passed in a parameter. Now once again, to prove that there's no correlation between the number 1 in the first slot, or the first positional parameter, and what's being echoed, let's change this value for slot 1 to the value 3. And as you can see, Bash still echoes that we've passed into the script pos param 1.shell, 1 positional parameter. Let's add some more. The second slot will contain 9, and Bash sees 2 positional parameters. Now what if we were to append to the 9 a value such as 4 without spaces? Bash still sees these 2 values as 2 positional parameters. Positional parameters are separated by spaces. So the extra value 4 becomes joined with the 9 because it's juxtaposed to it. So as a result, it's considered 1 value, and that value is 94. In other words, 2 positional parameters. So now that you know how to echo the number of positional parameters that the shell has recognized that you passed into the script, how do we use them? Well, let's show you. We'll modify pos param 1.shell, and within here we can work with the positional parameters. We can do things. For example, we've shown you earlier a simple program called Sequence. Sequence can generate numbers on the fly, and its default is to generate numbers with increments of 1, but we can of course alter the increment. Let's say we'd like to run the Sequence program, but we'd like to make use of the positional parameters. So fine, within the script we simply run Sequence, and we take in the first positional parameter, which is located at value number 1, slot number 1, and we take the second positional parameter at value number 2, or slot number 2, to indicate the min and the maxes. So 1 will be the min, 2 will be the max, and we'll put some basic values such as 1 through 100, and you'll see how it works. Great, let's source this again. And as you can see, Sequence prompts us for help because we didn't pass in any variables for it to use. So what this means is as follows. We need to specify 2 positional parameters so that Sequence can go off and run the sequence for us. But additionally, we should increase the intelligence of our script. We should at least have a condition that catches the lack of proper number of or sufficient number of positional parameters. But before we go on to fixing the script, let's just at least run the script. We'll pass in 2 positional parameters. We'll begin with 1 and we'll end with 100. And it runs nice and neatly. However, if we mess this up by not specifying one of the options, then we get an unexpected return. For example, I've specified here just 1 positional parameter, so Sequence has done 1 to 1. If we specify nothing, Sequence complains. Let's fix this script so it's a little bit more intelligent, and you'll find this in many of the system scripts that ship with your Linux distribution. So before we let Sequence even run, we should stop the user dead in his tracks to let him know that he's missing the requisite number of positional parameters. All we need is a simple condition. And that condition, since you're now condition experts, is run or executed using if, and we'll simply say if the variable which stores the positional parameters, that's the # or hash mark variable, is equal to 0 or less than 2, that's another way to say it, or less than 2, then we have a problem. Or we can also say not equal to 2. A few ways we can test, because the Sequence command requires 2 particular variables. So we could say not equal to 2 and we'd be right on the money. So if we don't see 2 variables, something's wrong. Then what are we going to do about it? Well, we're going to echo this script requires 2 arguments. And then we could do something such as typical usage, or for example, like you typically see when you specify an incorrect number of arguments or the wrong arguments for other shell scripts. And then we can end the logic here. So before anything else is permitted to run, before Sequence is permitted to run, and we can put a little comment here, begin Sequence. So before Sequence is able to run, the condition checks to see whether or not the number of positional parameters is equal to 2. We don't care if it's equal to 1 or 3. We want it to be equal to 2. If it's not equal to 2, echo that this script requires 2 arguments. But guess what? This script will still continue to process, because after the condition has run, Bash will simply begin running the Sequence command. So what we need to do here is make use of the shell built-in command exit. But we should exit with an error. We shouldn't exit with just 0, because this script, from the administrator's perspective or from our perspective as the programmer, is not successful. So we want to exit with a value, and it's customary to define the particular variable that houses your bad value somewhere else, like at the header of the script. So let's define a variable. And we can get rid of this echo line, but we'll keep it there for now just so that you can see it. We'll define a variable, and we'll call that variable bad param. Bad param is equal to some error, and let's call that error, or label that error 165, which is common. I'm using 165 because many of the scripts that you'll download, free scripts for example, or ones that ship with your Linux distro, will include some sort of bad parameter definition that equates to 165. So just to be in line with what everyone else is doing. So what we'll do is we'll exit with bad param. Now certainly typing out bad param twice is longer than, or requires more effort than simply typing exit 165. But by doing so, this enables us to make changes to bad param at the top without actually modifying the body of the code. So this will exit with bad param, or at least set the error level to bad param, which is 165. And as we've shown you before, exit will actually close the shell window. But nonetheless, we want to exit with bad param. We want that to be 165. Now let's proceed. And let's source this particular script file again. Now as you can see, it's exited. And we'll show you why. Let's flag this particular script. It's exited with the right parameter error, right exit status. Let's flag position parameter 1.shell to be executable. And just by root, of course. And let's run positional parameter 1.shell. Now when we run positional parameter 1.shell without sourcing it, it exits. It exits with 165. We can echo that bad value that's stored in our variable. This is the bash kept variable. It exits properly. So that's something else that you should have picked up on. If you source a script file and the script file contains an exit command, that exit command will close your shell window. However, if you flag the script executable, as we've just done, and we'll lsltr to show you again, if you flag it as executable and then run it, what happens is bash instantiates a subshell. So the exit still occurs, but it occurs within the subshell, which you don't see, giving us control once again within our shell. And then it says this script requires 2 arguments. And we're still echoing here the number of parameters. Now let's feed into this particular script 1 argument. And it still doesn't like it. It says this script requires 2 arguments. If we were to echo the error level, the exit status, it's still 165. Let's feed positional parameter 2 values. And remember, positional parameters are separated by spaces. So we'll feed it 1, and we'll also feed it 10. Now voila, all of a sudden the sequence command has run. It's begun, and it's run all the way up to 10. Now ignore this first line. This 2 that you see here is the echo of the number of variables, or the number of positional parameters that the script has been fed. And we can modify the positional parameter 1 script to essentially comment out that line, this line right here. We'll comment it out so it doesn't run, and show you that again. Let's clear the screen, and we'll run positional parameter 1.shell with 2 values, 1 through 10. It runs with 1 through 10. But the second we drop the second positional parameter, it complains. This script requires 2 arguments. Do it again, take off all the arguments. This script requires 2 arguments. We could have put another line that says you've entered 0 arguments. Let's show you that. Let's modify positional parameter 1.shell, and before we exit, we'll just simply say you've entered. Now, because we're about to do the single quote here, we should use an escape character. That's good practice. So let's just enclose this within double quotes, and we use the escape character. You've entered. You don't have to if you remove the quotes, but it's just good practice. You've entered, and we'll echo the positional parameter variable arguments, or parameters. Let's say parameters. And then we'll close this with double quotes. Let's try to run this again. You've entered 0 parameters. Then we can check our escape sequence to see what it doesn't like. But nonetheless, you've entered 0 parameters. Let's give this 1 parameter. You've entered 1 parameter. Let's give it 3 parameters, which we've yet to do. And it says you've entered 3 parameters, so it's still wrong. But if we give it 2 parameters, it runs nicely. Let's modify that shell script again. And it's quite easy to work with. Excellent. So you know how it works. You know how positional parameters work. It didn't like our escape character. We can easily fix that. In fact, if we remove the quote and return to the shell, then it doesn't like the single quote, so we need to escape it properly. But nonetheless, you understand positional parameters. You understand how to echo all of the positional parameters that the script sees. You know how to stop a script before it runs, and you know how to essentially harness them. One other note, if you have a script that requires or runs with more than 9 or 10 or more positional parameters, the way you access the 10th or more positional parameter is to echo the variable as follows. Open braces, and then the number, close braces. That's something else you should know. Perhaps this is a bug that will be fixed in a later version of Bash, but as it stands, if your shell script, which is very rare, requires 10 or more positional parameters, the way you'll gain access to those positional parameters is to echo using the format we just showed you. Now we can rerun this, and in fact we didn't fix the escape sequence, which is here. Let's exit, rerun, and it's run, and we can put X number of parameters. It'll tell us you've entered 3 parameters. It's wrong, you name it, but if we enter the right number of parameters, it works. So that's positional parametering. It's important because you can drive your scripts using positional parameters, and just think about the power. For example, you could read values in from a text file, or you can feed the values directly into your script, and then your script becomes even more variabilized, more portable, because then it can operate on the fly. We showed you a simple example with sequence, but once you understand the simpler examples, you can read and write more complex examples based on positional parameters.